Hello everyone and welcome back to another video of the Hidden Quantum Champions. Today we are looking into a company called TuringQ from China, and if you have never heard about them, then for sure you should stay tuned for today's video, because I think this company is gonna pop up on people's radars very soon. And with that, let's hop right into it. So here we are, as always, on the website of TuringQ. And it says, driving computational power transformation with photonic chips and quantum computing. And then new product release link down here. It says first quantum artificial intelligence computing center, first photonic chip pilot line. And there's also some video linked here. So obviously we are looking, from what we can see here, at a photonic quantum computing company. So a approach where we try to use light, which is bosons, photons that behave bosonically, in order to do quantum operations. So let's move on. Let's see what else it has to tell here. So the first domestic photonic chip pilot line. Thin film lithium niobate, so LNIO photonic chip technology. So it says down here, processing capacity based on the new generation photonic integrated optical materials, lithium niobate thin film, compatible with CMOS process. CMOS is the processing technology that is being used for today's computer chips, that is being used in all the big fabs that produce basically the world demand of computer chips. It says building ultra large scale programmable photonic chip matrix, relying on pilot line for fast iteration and mass production, and then accelerating the transformative development of quantum computing, artificial intelligence, optical communication, and other fields. So the next focus on next generation information technology and industrial application. And over here it says less than 0.1 dB per centimeter waveguide loss, more than 100 gigahertz of bandwidth, more than 10 layer chip architecture layers, and then 160 times 160 photon matrix scale. So this all refers to, let's say, technical benchmarks of the photonic circuits. So the circuits that later on execute the quantum operation that are being printed on those chips with lithography techniques. There's another one over here where it says FSDLW 3D photonic chip technology. So autonomous on-chip 3D photonic integration, processing capacity, and then full self-controllable iteration time less than 3 days, monolithic integration of the world's largest scale identically scalable quantum light source array, complementary CMOS process, so through 3D integration, and then preparation of the world's largest scale 3D integrated optical quantum chip. So very exciting. More than 30,000 photon circuits, monolithic integration, more than or equal to 50 layers, 3,000 number of modes, less than 5% coupling error, and again less than 0.1 dB per centimeter transition loss on these chips. And that is all to say there is a chip pilot line that is domestically, so I guess within China, integrated or built for this type of chip processing. Very interesting, of course, on many different levels. So this is, I guess, a leap towards establishing oneself as an expert or as a leader in the photonic integrated circuits domain. So then we see here TuringQ Gen 1, the world's first commercial research-grade optical quantum computer, so using self-designed and developed quantum chips as the core technology supporting the research and exploration of frontier, I guess, quantum. I'm not going to expand too much on that for now. Key indicators is quantum light source brightness is more than 500,000 pairs per second, pairs as in photon pairs, because you probably want to have a pair of photon which you can entangle, where you can also do superposition and entanglement or interference experiments with. So you need these pair of photons and you need many of those in order to be able to do a proper computation, because if you only have one, of course you cannot do many of these interferences, so you cannot really build interesting quantum circuits. So you need something that can produce many of those, and that's why this quantum light source is important. Then, of course, the low loss is also very important, because you want to make sure that you don't lose one of those two photons, because otherwise you are basically producing errors. You cannot really use them anymore in order to perform computation. Chip layers more than 49. Quantum algorithm fidelity is above 90%, interference contrast is above 95%, and monolithic integrated photon circuits is 30,000. We've seen that before. I will not go into the details of all of these numbers now. First of all, because I'm not an expert on those photonic circuits, and secondly, because I don't want to explode the length of this video. If you are interested in photonic circuits, if you want to learn more about it, let me know down in the comments below, as always, and then we can make a separate video guide on this topic and hop together into this domain. Other products that we see here is the Q Matrix, so world's first on-chip optical quantum computing platform. That's, I guess, like the, let's say, scaled down version of this one here. And then we see the anti-quantum encryption chip, the world's first high-performance quantum encryption chip, I guess, which is probably for the harvest now, decrypt later, so quantum encryption type of processing, where you are like using quantum safe encryption methodologies, or possibly a quantum random number generator. That's because I see here QRNG, which is usually a chip that uses quantum physics to generate random numbers that are then being used to do encryption type of tasks. But sometimes these chips are also used for simulations, because sometimes if you do, for example, Monte Carlo simulation, you need to have a random number, and that's where some hardware like this can be interesting, and we've seen that with other companies in the Hidden Quantum Champions before. Then we see here the software platform. So there's also a software stack that is being developed to probably drive those quantum computers. We see Quantum Peak, so quantum computing development platform, adopting a classical quantum hybrid computing architecture, helping users conveniently use quantum computing power. And then there's Deep Quantum, efficient programming framework for quantum machine learning and optical quantum computing. And that one, I think, is also available on GitHub for you to check out if you're interested in that. Then integrated hardware and software product systems. So here we have, let's say, the whole overview over the product range. We see there's quantum hardware and quantum software that we've been talking about. There's a quantum security side, so enhancing the security of traditional encryption systems with core technologies of quantum keys and post-quantum algorithm compatible. That's what we've seen before here, right, with the chip, so that then gets integrated into something that can be upgraded to a compute system. And then finally, we also have here the optical connectivity, so breaking through the bandwidth bottleneck of optoelectronic chips with core photonic chip technology. So that's kind of, let's say, the downscale or the component side of this quantum hardware that we've seen before, right? So underlying, you have to have some chips that can actually do these integrated circuit things, and I think these are also being sold here. Now we come to the application space, and I guess we see the usual stuff that we also have seen with other companies in that space, right? So there's quantum, there's finance-related applications, biopharma, so material science, I guess. We see quantum security, so national cryptographic algorithms and post-quantum algorithms building quantum shields for industries such as government affairs, energy and water conservancy. There's smart transportation, so logistics related topics. On top of that, we also see quantum intelligence integration. So independently developing a new generation of optical quantum computing systems, creating a heterogeneous hybrid computing foundation of supercomputing plus intelligent computing plus quantum, helping users to permanently lay out quantum frontier technologies and products. And then there's an education branch helping people, and I like the coining here, to learn about new quality talents in the post-Moore era, so the time where we are not anymore, let's say, looking into the Moore type of chip scaling of classical chips. Okay, then about the Turing Quantum, so about the company itself, we see here 20 years technical accumulation. So I guess the company, the expertise within the company is 20 years. 70% have a master's and PhD degree, and 200 plus invention patents are being filed by this company. And I mean, the whole patent story is very important also in the whole space of quantum technology. If you want to have a, let's say, deep dive session onto that, please let me know down in the comments below, because then we can do a specific video on this topic as well. We also see here an overview over the cooperative customers that are already using this. I'm not going to go into the detail because most of the companies I don't know, but it looks like many of them are in the research and also in the technology space, and most of them, they're actually Chinese companies, Chinese universities, Chinese research players. There's a very couple of exceptions that you might be tracking here if you are looking through it. Same is true for the investors. I will just quickly click on it, but I'm not going to go through all of those because most of them I cannot really say much about. There's a news section down here, which is mainly flashing news from 2024 and 2025. I'm recording this in 2026, and even though it might look like there's not much activity ongoing here, I can tell you that I think there is, because there's also news on other sites around TuringQ, and also if you're looking at the, for example, repository, you see that things are being updated on a regular basis. Finally, there's, as per usual, a way to get in touch with them and to contact them, and some links down below here, stating, for example, that the headquarters is based in Shanghai. Later on, when we see in the company, we will also see that there are other locations as well within China. Now let's quickly go back up, and then we are looking at the core technology. So let's quickly check out the chip, the photonic chip technology that we have here. So it says the lithium niobate is a multifunctional crystal material with excellent comprehensive performance, characterized by a wide transparent window, moderate refractive index, large linear electro-optic coefficient, and good temperature stability. Since the industrialization of lithium niobate thin film wafers in 2014, lithium niobate, with its superior optical properties, has provided a new platform for integrated optics in the form of LNOI, lithium niobate on insulator. Building on the traditional characteristics of lithium niobate crystals, LNOI materials offer enhanced light confinement, modular efficiency, and integration density. TuringQ leverages the next generation optical material, thin film lithium niobate, and focuses on the entire research and development chain of photonic chips, from design, fabrication, packaging, and testing to system integration and quantum algorithms. By developing LNOI photonic chip technology compatible with CMOS processes, TuringQ opens a new era of photonic chips. And I think that is pretty much describing also the bet that this is about. It's not only about building the quantum computer with some specific technology, but it's more widely spread, right? It is about developing this technology, and even though maybe the quantum computer is not the first thing that you can do with it, there's other stuff that this might also be interesting for, because it is actually more developing a CMOS compatible photonic chip technology that can be integrated into all types of chips, right? And then on top of that comes the integration into quantum systems, into algorithms and so on. Advantages: so mass production, CMOS process compatibility enables large-scale production, full chain capability, so possesses full chain R&D capability from photonic chip design to production, enabling rapid iteration. Mature process has the capability for full chain production of CMOS process equipment, and then independent and controllable, so domestic photonic chip pilot line, fully autonomous control throughout the process, avoiding dependency issues. So again, we see some topic here also about, let's say, the global situation and the supply chain, supply chain control that we also see with this Chinese player here. Not only in other areas in this current situation, right? And there's some information about the process metrics. I'm not going to go into the details of those because I think we've seen similar stuff before. Representative achievements, so photonic electronic co-packaging for optical computing, a rapid solution for the AI era. Photonic electronic co-packaging, PEC, is an innovative integration technology that packages photonic and electronic chips together. This approach not only reduces size and enhances computational efficiency, but also lowers power consumption. The emergence and rapid expansion of large model training applications have accelerated the AI industry, increasing the demand for higher computational power while significantly boosting energy consumption and costs. PC technology offers a new solution to meet the AI industry's needs for low power consumption, low cost, and high efficiency. TuringQ has been dedicated to overcoming core technological challenges in PEC, combining with the lithium niobate thin film photonic chip technology to develop various co-packaging products and technical solutions. So here again we see what I was just pointing towards, right? It's not only about coming up with some new implementation for quantum chips, but this co-packaging is also interesting for other applications, especially when it comes to moving a lot of data. And by the way, this is just something that we have seen over the course of the last decades to be happening, right? So in the very beginning, people were putting those fibers as intercontinental lines between the different continents. They were putting big fiber cables down into the ocean to build this connection, and these were considered the data highways, where you could send much more data than on the landlines, which were back then all still copper. And we've seen that since then, the distance at which you apply those fiber lines has become shorter and shorter and shorter. So at the very beginning, there was only this maybe intercontinental line. At some point, you would also have these lines between the different nodes in the network, in the internet network. So then between the data centers, and nowadays you see that they are basically going into the houses, into the private domestic houses. And if you then look into places where there's a high amount of data movement, you might even already see them between the computers themselves. So for example, I remember that when I started my research, which is already a while ago at CERN, there was already the implementation ongoing of having those fiber connections between the different compute units in the supercomputing center. And now, thinking this forward, the distance gets shorter. So eventually you will have those lines, those highways, those data highways, optical data highways on the chips right away. So that's exactly where this goes into. You will have these photonic electronic interfaces on the chip itself. So that's kind of, I guess, the idea here. That's where like AI is also interesting, because you're moving a lot of data back and forth. You have these huge matrix multiplications happening all the time. And that's where this might become interesting. So that's also why this technology bet is not only on quantum, but more on photonic processing on a chip. Quickly on the advantages named here, so integrated photonic chip technology, optoelectronic co-packaging for optical computing, heterogeneous hybrid 3D stacking packaging, supports tile-based scalability, on-chip optical wire bonding suitable for mass production, and then low latency optical operator 49x49 optical matrix. So you see a lot of points that also point towards mass production products, right? So you have the CMOS being mentioned here. You see the wire bonding technology that is being used in chips already. So many things that point also towards, let's say, and then the pilot test line, right? So many things that point into this direction. And again, you see here some related products going probably from a chip, at least that looks to me like a chip, all the way up to integrated products like the whole computer via these different elements here. Okay, let's quickly hop back on the core technology side. So now we have talked about the, let's say, connections, right? The connectors. Let's also quickly take a look into the light source technology. So I guess that's what this is about. Femtosecond laser direct writing. Oh, okay, no, this is a production technology. So technical introduction, femtosecond laser direct writing, FLDW, is a micro-nano processing technology that focuses pulsed laser beams on the surface or interior of materials. Through the nonlinear interaction between the laser focus and the material, it alters the material's properties. The unique processing method of FLDW allows for the creation of arbitrary three-dimensional structures, paving the way for on-chip 3D photonic integration. Quick point on that, you might know these little glass cubes that you sometimes find in tourist shops where there's like little images of some tourist sites. I don't know, for example, if you go to Berlin, you will find it with the Berlin Gate laser engraved into the 3D cube. So this is also done with a laser usually, as to my knowledge. And I mean, technically, this, what we are talking about here, is similar. It's not the same. This is happening at a much higher precision and with a completely different, let's say, technique, but the idea is very similar. Now back to the text. TuringQ specializes in ultra-precision femtosecond laser processing technology, focusing on solving key challenges in future quantum information technology and massive data storage technology. With over a decade of rich R&D experience, TuringQ has developed a fully autonomous and controllable technology pipeline from cutting-edge processes to advanced platforms and industrialized equipment, accelerating the application of femtosecond laser processing and intelligent laser direct writing equipment. There's another thing in here which I find interesting, which is also to be pointed out, and that's the storage technology. So what is interesting about that is to use light and kind of, in this case, maybe a glass to kind of store information, because one, that works completely without it is stored completely without energy usage, right? So you don't have to keep it on like the flash memory or the random access memory on your computer. But it's also not stored in any like magnetic way or something where you could have electromagnetic interference field destroying or wiping out the data, which is the case with most of the other computer technologies that we are using today to store information. Which is also a reason why you should not just put your stuff on a hard disk drive, put it in the shelf, let it sit there for many, many years, and then take it out and expect that everything's still working, right? So there are, let's say, data storage best practices. And I think storing something like this in a glass tray is something that also others have been looking into or working on actively, and there are good reasons to do that for specific things. Okay, representative achievements. The monolithic integrated array chip with 128 identical quantum light sources is currently the largest reported scalable array of identical quantum light sources, fabricated the world's largest three-dimensional photonic quantum chip and demonstrated the first true two-dimensional spatial quantum random walk computation. And then, yeah, I think you see here these what these circuits would look like. You have these different coupler elements, and then you can basically use them and tune everything to kind of do interactions or not do interactions, and thereby kind of code your algorithm. Now, let's quickly see what else we have here. So I think these are more on the software side. Yeah, Quantum Optimus, self-developed photonic quantum computing development platform. I think we've seen that before. Enables classical quantum hybrid computing, supporting convenient algorithm development and visual training display. It supports the development of multiple classical quantum hybrid algorithms, quantum heuristic algorithms, and on-chip quantum photonic optimization algorithms, offering cloud-based development, dynamic clustering, easy development, and rapid deployment advantages. Click on try. So that's the call to action. And I mean, if you want me to try this out, you know what you have to do. I'm not gonna point it out again. And then, oh, sorry, now I've clicked on the wrong one. There's another one, right? There's the deep quantum. And I mean, if you are interested in that, I guess it might be worth also checking out the Git repository. I will quickly turn on the translation here. So deep quantum, efficient programming framework for quantum machine learning and optical quantum computing. And there's a tutorial available here and the guide on how to install it, as well as an overview of the whole framework. And I'm not going to go into all of these details now. Product Center, I think we don't have to go through all of this again. Just to show, there are other products available here as well, right? There's the TuringQ Gen 2 large scale system, which I guess is the follow-up to the Gen 1, which is probably the scale up of the Q matrix. We also see some, I guess, more educative tools here, like the Q Lite, which looks to me like a setup where you can do some testing with it. The Q Box, which I don't know, might be some scientific equipment. We will click on that in a second. Time correlated single photon measurement equipment, I guess. That's probably what you need to kind of drive these applications internally. So to measure the single photons, right? Single photon detectors that then later on translate in the computed quantum information. And then there's the femtosecond setup that we've just talked about, which I think is used to write these circuits. Now let's quickly click on the Q box, because that was the one where I didn't really have an idea on what it could be about. So let's quickly see if there is anything that we can find out here. So TuringQ, leveraging cutting-edge research in quantum computing and artificial intelligence, introduces a systematic quantum curriculum for all education stages. It features a high-performance quantum simulation platform and an interactive course platform characterized by AI teaching assistant and tailored to the quantum field. The platform is built on tensor network technology, offering a simulation with over 100 plus qubits to meet educational needs and advanced scientific research. It aims to foster innovation, talent in quantum information, artificial intelligence, quantum computer science, and physics in higher education institutions. Okay, so that's the education product. I guess it's a quantum simulator. Generally, I like this idea of also using these platforms, of also using quantum technology to get people educated about it and make sure that like there's some talent that is also following up on that, because for sure this whole quantum technology thing is a long-term play and it needs some time to kind of get to the stage where as a society we can really profit from it. And I think it's very important that we are aware of the fact that we also need talents and we need people to kind of grow up with this and to support this whole endeavor. Okay, I think that's everything on the product center. On the solution side, I mean, we've seen most of these topics being discussed before, so I'm not going to go into that. Instead, what I would like to do is to quickly check out the About Us page on the company itself. So, driving computational power transformation with photonic chips and quantum computing, become a global leader in the integrated application of chip, light, intelligence, and computing. Company introduction: Turing Quantum is a leading company in the industrialization of optical quantum chips and optical quantum computing in China. Based on photonic chips and quantum computing, Turing Quantum has created an integrated product system and launched fully autonomous and controllable solutions across industry, driving computational power transformation. Turing Quantum is committed to promoting the integrated application of chip, light, intelligence, and computing, and actively partnering with Shanghai Jiao Tong University, I guess I pronounced it incorrectly, and ChipX to establish the first photonic quantum chip pilot line and industrialization base in China, and the first quantum artificial intelligence computing center in China, leading the domestic optical quantum computing technology to achieve a leap from academic exploration to commercial application, laying a solid foundation for the industrial development and optical quantum computing. Turing Quantum was founded in 2021. The technology originated from the Integrated Quantum Information Technology Research Center at Shanghai Jiao Tong University, founded by Professor Xiaomin Jin. Oh, I probably also mispronounced that. Sorry for that. He returned to China in 2014. Turing Quantum currently possesses core technologies and processes for 3D and ultra-high-speed optical quantum computing chips with independent intellectual property rights, and has the full chain R&D capabilities from chip design, tape out, packaging, testing to system integration and quantum algorithm implementation. As of 2024, the company holds more than 200 patents of various types and nearly 100 copyrights, with technology always at the forefront of the industry. The company has completed 4 rounds of significant financing within 3 years of its establishment, with a valuation close to 3 billion yuan. It is jointly invested by well-known institutions such as CICC Capital, HOPU Investment, Lenovo Ventures, Orisa Holdings, Legend Capital, and others. And then there are also some honors and awards listed down here. I am not 100, I don't know the exact currency exchange rate right now, but I think this will be in the, probably 3-digit millions of US dollars right now. Good. So then on the history, I think we are not going to go through all of these points now, but what is interesting is that in 2021, we see here Turing Quantum was officially established. We also see that there are some investment rounds happening here, so secured hundreds of millions of yuan. This is so 2-digit million US dollars. Here we see it another time in a pre-A financing round, then there's a A+ financing round, and we see another Series A financing round in 2022, and I think in 2025 there has been a B financing round. And I mean, if you want to build such a fab, such a pilot line, you also need quite a lot of money, so it makes sense that this is happening. Then we see here the founder, which we have seen before. Besides his activities as a founder of the company, he has also previously been working in many other international places. You see, for example, here, recipient of the National Excellent Doctoral Dissertation Award, Marie Curie Fellow of the European Union, Oxford University. Has been at other places before. Personal awards are also listed down here. Quickly about the team as well. So the core team of Turing Quantum consists of outstanding young scholars from top domestic and international universities and research institutions such as Oxford University, Imperial College of London, University of Toronto, Chinese Academy of Sciences, Tsinghua University, Shanghai, Jiao Tong University, which we've seen before, and the Fudan University. It is currently the only team in China that possesses chip fabrication, quantum computing, photonic computing, plus artificial intelligence technology. There are has 200 members, and over 70% of those have a master's and PhD, with offices in Shanghai, Beijing, and Wuxi. I'm not sure if I can pronounce that correctly. So different places within China. I think that's it for today's video. I hope you found it interesting. So TuringQ, for sure, a company that should be on the radar of the hidden quantum champions from my point of view, and will pop up probably on many people's radars very soon, not only because of their quantum technology advancements, but also because of them pushing the development of photonic chips, or photonically integrated chips that are CMOS compatible. I hope you liked this video. If so, please make sure to give it a thumbs up, and I'm looking forward to see you in the next one. Until then, bye bye.